So this is the question which I have practiced today. Okay, so what does question says that for climbing staircase it takes n steps to reach the top, and we can take either one or two steps. In how many distinct ways you can climb to the top? So by looking this at this question itself, we know that it's a recursion question, right? So either we can take one step or two steps. So we have to find out the distinct ways we can climb to the top. So let's say for the if total number of stairs are 4, right? Let's say total number of stairs are 4, and we can take either one step. So total number of stairs left is 3, or two steps. So total number of stairs left is 2. After that, again at this step also we have two choices. Either we can take one step, so total number of stairs left 2, or either we can take two steps, total number of stairs left is 1. Similarly for this one, if I take one step, if I take two step, I reach to the top. 0 means I reach to the top. So for here, if I take one step, if I take two steps, I reach top. Again here, if I take one step, I reach to the top. So this one is again I reach to the top, right? And if I take two steps here, I will become kind of a negative, right? So that is not we exactly wanted where I reach to the top, exact top. So we are only looking for 0, 1. Okay, so this is finished, and here if I take one step, I will reach to the top. Again here, if I take one step, I will reach to the top. If I take two step, it will be negative. If I take two step, it will be negative. If I take here two step, it will be negative. So don't want to take this one. So what are the different ways I can reach to the top is this 1, 2, 3, 4, 5. Total 5 ways. So output is 5. 1, 2, 3, 4, 5. So one step, one step, one step, one step here. So I took one step here, one step here, one step here, one step here. So that is 1. And 1, 1, 2. So 1, 1, 2. So this is another step. 1, 2, 1. So I have taken 1, then this 2, and then 1. So this is the third step. So you got it right. How with the tree, all the possible recursion, we have to compute what are the distinct ways. So we have to just return the number, not the different paths, right? So using the same methodology itself or approach itself, I wrote this recursion program approach 1, but that is actually I encountered this time limit exceeded. So what I did was is the same thing. I passed the recursion. This is my recursion method which I have written. If it is less than 0 means I am reaching this point. Less than 0 means reaching this point. I don't want to count that. So if it is less than 0, I am returning 0. Only if it is equals to 0, I am returning 1. Only if it is 0, I am returning 1. So these are my, you can say that recursion breaking conditions. And I am iterating for each either n-1 plus n-2, all the steps. So go to the left, go right, then go left, go right, and do sum of all the different ways we can get. And when it will return 1, only when n equals to 0, 1 will come. But with this time limit exceeded comes. So why the time limit exceeded come is here. So even if you see this solution itself. So what was that? 4, 3, 2, 1, 0, 0. Here was 2, 1, 1, 0, 0. Right. So here if you see that, you will notice one thing. Okay. So I was trying to see that how to remove this time limit exceeded. So here if you see that we are recomputing one. So see this 2 and this 2. They are same. So if I have done the computation here, why I need a same computation need to do for this? Right? Similarly, if I have done computation for this one, why I need to do the same computation here and for this one also? So there is a lot of repetition of work happens here. So I tried to reduce in the approach 2, which actually works out for me using this. So this is the memoization. So recursion plus memoization. So it is, I have solved through recursion plus memoization. So, but this one doesn't, approach one doesn't work. So what is the time complexity for the one? So here if you see that at every step I have two options. Either take one step or either take two steps. At each step I have again either take one step or either take two steps like this. So it will go like this. So whatever the height of the tree, so what is the max height of the tree? The max height of the tree would be n. So n is 4. Let's say 4. So I took one step, I take one step here, I take one step here. So one left, I take one step here, one left. So what is the maximum height? It will goes to n itself if I take one step, right? And at every level I have two options. So time complexity is 2 raised to power n. Big O of 2 raised to power n, right? So that is the worst case time complexity for this approach one, and that's why it didn't work. I got time limit exceeded. And with the memoization, I have used the approach where I avoid using the recomputation. So what I did is, here I show you that the same solution, but I have taken one space also. So here in this case 4 3, right, 2, here 1 2 1, right? So here 1 0 0 0 1 0 0. Okay, so here what I have done is I have taken an array stairs versus count. So maximum there are 4 stairs. So here I am taking an array of whatever the n number of stairs given, right? So n plus 1. So 4 is given, right? So array start from 0. So 1 0 1 2 3 4. 4 stairs. So I need n plus 1. 1 2 3 4 5. So I need, even if n is given 4, I need 5 size. So that's why n plus 1. So what I am doing is, so when I am doing a recursion, so now let's say for 2, I get to know that what are the number of distinct ways I can reach to the 0. So in 2, I can reach at 2 times. There are 2 different ways I can reach to the top. So at 2, I will put 2 different ways I can reach to the top. For 1, when it is 1, I know that how many different ways I can reach to the top? Only 1. So I am putting it here. So when it is number 3, what are the different ways to reach to the top? 1, 2, 3. So 3 different ways to reach to the top, right? So now let's say when the recursion comes to this point 2, right? So when it comes to the 2, again I don't have to go and compute again. I don't have to go and compute again, because it will say that I have already computed. Then there are 2 stairs left. What are the different ways I can reach to the top, right? So I have already computed that part. So I can reuse it. So here if you see that I am reusing my computation what I have done before. So that's the thing, only I am doing it here now. So here the same recursion I am using, but I am passing this array of n plus 1 size, the same condition, 2 breaking condition, but also I am checking, added one more condition, that if whatever the step would be currently I am at, if it is greater than 0, if I have already computed that, return that. No need to do the computation again. If I have already computed this part for 2, why you have to compute this again? No need, right? So that's what we will avoid this part, recomputation again. And you just added what are the different ways, and I am also storing it in the array, Like for whatever the n I am doing the computation, I am also storing it into that n and returning it at the final. So this is a normal recursion, and this is generally called recursion plus memoization. Uh, Maybe I'm pretty much sure, like, if you might be knowing dynamic problem, I think this can be solved to dynamic problem, but I am not pretty much good at DP. But recursion with memoization, I actually find it a little bit easy then. The only difference is recursion with memoization is top to bottom and DP is bottom to up, right? So, but I find this recursion plus memoization little bit easy to approach. So here it is accepted and it's in the runtime, it's beat 100% of users with the Java. So what is the time complexity here? Time complexity here is big O of n, right? Why big O of n? Because here if you see that the number of steps, for each step we are computing only once, right? So first 4, 3, 2, 1, you have to do computation. But during recursion, if you again found 1, you don't have to recompute again. You have already done the computation. If you found 2, you don't have to do the computation again. You have already found the computation. So time complexity is big O of n, that we are doing only computation one time only, right? Space complexity here, if you see that space complexity is also big O of n only, right? So we have to take the stairs array plus there is a space complexity for the recursion also. It maintains a stack, but overall it will be big O of n only, right? I have spent a good amount of time in finding the approach 3 also, where the I can minimize this space complexity to big O of 1, but I couldn't find that. But if you have that answer, please could you please post it into the comment section, right? Thank you guys, that's what I did today. Bye.